Janet, are you there? Hello, can you guys hear me?
Yes.
Okay, I'm so sorry I'm late. Thank you for hanging in there. Well, today I just wanted to open up the discussion to any questions you had. So please feel free to jump in. Okay, I see we've got McKenna Noam Josue. Josue, did I pronounce your name correctly?
Yeah.
Okay. Okay. Janet and Mattia. So I didn't have anything in particular. I did finish up the video for Tuesday's session, and I'm about to post it, so you'll have that in your Canvas announcements list, and you can refer to that video for the solutions that we went over on Tuesday at our Zoom session. Okay? So let's open it up for discussion. Are there any questions?
I have a question.
Yes, go ahead.
So I was wondering about the formatting, if it was going to be like the worksheets that you have posted for us so far, if that was going to be the formatting for the midterm.
Yes, yes. It'll be 5 questions as you saw in your worksheets. And as you saw in your worksheets, these questions will have various parts. And the exam will be worth a total of 100 points. So I'll scale up on the grading in terms of your solutions. Now, I do want to say something about your solutions. They must be given to you they must be given to me in some detail, okay? So I can't just accept an answer. You have to justify your answer the way that I've indicated in your solution sets, all right? So let me, for example, let's see if we can open up one of these worksheets that has the solutions on it. Let's look at, let's see. Okay, let me open up my directory here. Okay, I'm going to share with you now this this document here. Let me open it first, and then you'll be able to see it here. All right, so let's see. Let me just open up worksheet 4 here. Okay, and then I'll see if we can get this up on the board here. All right, can you guys see this worksheet here? Hello?
No, I can't see anything.
I can't
Okay.
either.
All right, let me see if we can open it up here. Uh, okay. Can you see it?
Yes.
Yeah.
Okay, good. Now, this is a good example of what we're talking about here, where, you know, when you read this problem, you say, okay, I'm gonna add up the counterfeit bills with the non-counterfeit bills to get a total, and then I'll divide the non-counterfeit by 175, and divide that by the total, which was 219,130. And so suppose that all you wrote down was this number here. Well, I wouldn't give you full credit. I would take off points, because even though the logic is arithmetic, right? This is just adding and dividing. Nevertheless, it needs to be written out. Okay, so I don't think I'm asking too much of you to go ahead and justify your calculation here, even though it's a trivial calculation, I admit, but it still needs to be written out in full. So here's basically really a single paragraph that shows you how to compute your solution. Some of you left it like this when I graded it, and that's perfectly fine. Okay? The reason I took the extra step to express it in decimal form was because we were going to use that value for P of A in the second problem here. And so to get the value of counterfeit, you multiply by the relative frequency times the total number of currency in the global market. Okay, and then putting this into scientific notation simplifies the answer a little bit, but as long as I see some justification here, for example, you say that the total value is the product of the probability times the total value. Some of this is, just a simplification, and here I wanted to express it in terms of billions of dollars. So if you left it like this, for example, I would accept that. Some of you did not use scientific notation, but you had the correct answer, right? You wrote out all of the zeros in your answer, and that's fully acceptable. Okay? Now, if you simplify it using scientific notation, that's a bonus, but I won't take any points off if you didn't do that. Okay? This one was a little bit more problematic in that I could not tell how you were deriving your answer. Some of you simply wrote the probability x greater than or equal to 1 is 0.019, and you left out this part, okay? And for me, that wasn't an acceptable answer, okay? So you have to write some semblance of an argument that says, oh, I understand what this is. It's really coin tossing disguised as quality control. And the quality control problem depends upon some basic probability theory in terms of writing out what the binomial distribution is. So several of you got very close to getting a complete solution here, but so, you know, when you look at the solution, it looks easy. You apply the binomial distribution with parameters n and p, where n is the number of phones in a lot, and the probability of a defective is 0.075%. So I'll be looking for, arguments that you will be able to justify and clearly state what the argument is, okay? And then, this answer here in terms of, is the probability high enough? It's slightly subjective, so you might have to argue that it may be high in some situations, and those situations depend upon the quality control protocols. Do you have any questions about the completeness of this solution here? Any questions about, is there too much in here? Is there not enough? You all see what I'm looking for. Okay. McKenna, are you out there?
Yes.
Is this understandable, what I'm looking for here?
Yes, it is.
Okay, good. Okay. Janet, are you okay with this explanation?
Yeah, it makes sense.
Okay, good. Any questions about this, what we're looking for in terms of a solution? Now, remember, I'll be posting this to your Canvas announcements tomorrow. Tomorrow is Friday, okay? And then you'll have until Sunday midnight. So I'm giving you some extra time here. Originally, I had planned to give you Friday and Saturday, but in our meeting on Tuesday, the students were asking for a little bit more time. And I know that you're working on worksheet 5. Not very many people have turned it in yet. I know you're getting busy. You're getting prepared for this midterm on Saturday. So you're working to get that in. I believe that one is due tomorrow night at midnight. So this will be due, our midterm exam will be due on Sunday at midnight, okay? All right. Other questions on your mind about the midterm or about these assignments that I've been giving you? Is that okay? Are
Yeah.
you guys okay with this so far? Now,
Yes.
looking ahead, sorry, was that McKenna or Janet?
Yeah.
Okay. Yeah, thank you for your comments. And remember also, we can stay in contact through the inbox. And a lot of you have been contacting me either through the cell phone, text, or an email, either to my Canvas email or to my other email address. So if you have any questions this weekend, I'll be on standby. You know, not 24/7, but I'll be on standby most of the time. So if you don't reach me the first time, please try again, and I'll try and respond to you. I've tried to respond to all of your emails and your queries as quickly as I can, and I hope it's been satisfactory. I don't want to leave you in the lurch for too long, so I've been trying to get back to you quickly and answer your questions. Okay, so you can send me questions and other queries this weekend if you have questions. Okay. Okay, this is your session, guys. So I'm waiting for your inputs.
I had a question about 4 and 5, questions 4 and 5 on the most recent worksheet that's due tomorrow, worksheet 5. Just like how I figured out the problem, I just can't quite figure out how to graph it on StatCrunch in order to like put it in.
Okay, let me bring that one up. Hold on for just a second here, and I'll bring it up out of the directory here. Okay. Let's work on the Word document here. Okay, can you see this document? Yes, no, maybe?
It's still on the worksheet 4 document.
Okay, it needs to figure out that we're looking at a different worksheet now. Okay, I think this is it here, worksheet 5. Okay, now can you see it?
Yeah.
Okay. let's see, is this Noah?
No, it's Mattia.
Mattia, okay. It's going to be hard to recognize you by your voices, but I'll try. Okay, so Mattia, which problem are we talking about?
4 and 5. Like I figured out the equations and whatnot. I just can't figure out how to graph it on StatCrunch.
Okay, all right, let's go into StatCrunch here. So we'll have to go back and forth between the browser and the document here. All right, so let's read the problem before we go into StatCrunch here. The overhead reach distances are modeled using a random variable called x, where we assume that x is normally distributed. All right. And let me write these numbers down, because when we go into StatCrunch, we'll have to toggle back and forth, and it'll help if I have these numbers already in tow. Okay, so let me just copy this down. All right, so I've got the information I need. Let me go into StatCrunch now. Okay, and let's see, let's put it here. And then I'll share this screen with you in just a second here. Let me see if we can bring this up. Okay. Let's take a second here to sign in. Okay, I'm just about there. And now let me share this with you. Okay, so the question was, how do we figure these probabilities out using StatCrunch graph? So here's our super function. And actually, what we're going to do is calculate this graph in the stat super function, Mattia. Do you see that? And what we're going to do is go to the very top function here, which is called calculators. And since our variable in the worksheet is assumed to be normal, we'll go down here and choose the normal distribution. You see that?
Yeah.
Okay. The other distribution that we've talked about is the binomial distribution. We'll come back to that later, but let me open the normal function. And here you get a graph of the normal curve. It's a bell-shaped curve, symmetric, and it's a positive random variable. Excuse me. It's a random variable defined over the whole real line. So let's do the following now. We want to calculate, and I know you won't be able to see this, but let me, here's our problem, and I've copied the data from the problem. But the problem asks us to find the probability that her overhead reach is between 194.5 centimeters and 210.5 centimeters. So what we're going to do is calculate the probability between those two bounds. So we're going to choose the between option here, and now you get a different graph. Okay, so we're told that the overhead reach is distributed normal, but it has a mean of 202.5 centimeters and a standard deviation of 8 centimeters. This is the overhead reach parameters. It's normally distributed, and it has these parameters here. Okay, So I want the probability of calculating, I want to calculate the probability that the overhead reach is between 194.5 centimeters and 210.5 centimeters, okay? So the way StatCrunch works is it'll give you the area, which, as you know from your reading, is the probability that the variable lies within this range. You see this graph, Mattia?
Yeah.
Okay, so we've gone, again, let's just recap what we did here. We went to the stat function. We chose the calculator function in that list, and we went down here and picked out the normal distribution. And when you start this problem, it'll give you the unit normal, won't it? Okay. And so we know that a linear transformation allows us to reformat the general distribution, whose parameters are mu and sigma. And if we use the transformation z is equal to x minus mu over sigma, then we can transform that into a unit normal. And StatCrunch does that for us. So we selected the between option. We set up the normal parameters for this x distribution. 202.5 is its mean. Mu, its standard deviation, is sigma equal to 8 centimeters. And then we calculated this probability. That is, we calculated the area under the PDF, which is the probability density function, okay? And that gave us the correct probability. So the probability is about 68%, okay? So there's our area underneath the PDF for these two endpoints here. Okay, now you had a question about number 5, Mattia?
Yeah, I did as well.
Okay, let me go back to my Word document. You probably won't be able to see it, but I'll read number 5 for you. If 64 adult females are randomly selected, find the probability that they have a mean overhead reach between 200.5 centimeters and 204.5 centimeters. Now here, we're going to use the central limit theorem. And the central limit theorem tells us that the standard deviation for a sample consisting of n adult females has a standard deviation, has the same population mean, mu, but the standard deviation for n is sigma over the square root of n. So what we'll have to do is we'll have to use our new z transform, okay? And let me write it right here, okay? So our new z transform, when we have a, sorry, let me see if I can, here we go. Okay, so let me write it this way. Z and so we'll use x. Let me use my equations here, and I'll write this in equation form. You can't see this yet. I'll open this up in just a second. So let's see, z is equal to our, let me just open it up right now so you can see what I'm doing, okay? All right, here's my Word document. Can you guys see this?
Yeah.
Okay, so I'm going to type in the transform, the z-score for the 64. So what I'm going to do is type in x minus mu here. Okay, so let me find mu. A little awkward here, but we'll find it. All right, and then here we're going to write the standard deviation of the 64, and the central limit theorem tells us that the standard deviation for the sum is sigma over the square root of n. So I have to divide by the square root of n. Okay, so that's the result that you're going to use here. Let me use lowercase n. All right. Okay, so what we'll do is we'll use the same mean, the same standard deviation, but up here, notice that we have n, the sample size, is equal to 64. Okay, so we'll have to take our standard deviation for this variable x, and since we have a sample of x's, all right, the standard deviation of the sample mean of those x's is sigma over the square root of n. All right. So let's go ahead and figure that out right now. Let me write. Let's see here. So we'll say, okay, the mean overhead. So we'll look at these parameters here, and now let's see. Let's take. Let's figure out sigma over the square root of n. So n is 64. So let's go ahead and write it here. So let me go ahead and take this denominator down here. A little tricky sometimes. Almost had it. Okay, so I'm going to copy and paste this right here. Okay, now what we need to do is scale this standard deviation for a single variable, because now we're treating the mean, and now let's set that equal to our standard deviation for a single variable, which is 8 centimeters, and then we'll divide by the square root of n. N here is 64. The square root of 64 is 8, so 8 over 8 is 1. Okay, so now we'll be using 1 for our variable z, which is this standard score here. All right, so let's go back to StatCrunch now, and instead of using a standard deviation of 8 for our denominator here, we're going to use 1. All right, so let's go back to StatCrunch now. All right, and so let's hide these. Well, let's see. We can use this graph here. Okay, so again, the mean of our new variable z is the same mean as the variable x. Okay, so we're going to type in the same 202.5, and now instead of a standard deviation of 8, x bar has a standard deviation of 1. Okay, do you all see that? That was our calculation. Sigma over the square root of n. Sigma is 8, n is 64, so 8 over the square root of 64 is 1. We'll go between again, and I didn't write the boundaries there. Let me go back to Word. You won't be able to see it when I go back. I'll be right back, okay, to my problem, which is here. And in number 5, we're looking between the bounds 200.5 to 204.5, all right? So let me go back to StatCrunch. So our bounds here in this problem are 202.5, oh wait, 200.5, and here the right bound is 204.5. And now we can compute that. And here's our probability, okay? It's over 95%. So let me just mention a couple of things here. It's really hard to see it. These two distributions are side by side. This is on the left side, you have the distribution of a single random variable. On the right side, you have the distribution of the sample mean. That is, you take 64 of these variables, they're identically distributed, and they're independent. And however, the central limit theorem tells us that this distribution on the right, which is the sample mean, it does have the same population mean. Oh, wait, yes. But it has a different standard deviation. The standard deviation is sigma over the square root of n, okay? So since its standard deviation is smaller, right? Here's 8 and here's 1. It's going to be a little bit more compressed around the sample mean, which is 202.5. So I think you can convince yourself that there's quite a bit more spread in the left graph. And so, you know, if you went out between 202, let's see, 200 and 200.5 and 204.5 here, you would get much less probability. So, so this is the graph, the correct graph on the front side. Okay. On the left, on the right side here, you get the graph for x bar. X bar has the same mean as x, but its standard deviation is scaled by the square root of n. And so you would get this probability here, okay? All right, so, so does that answer the question for number 5? Everybody good with number 5?
Yes, thank you.
Thank you.
Okay. All right, now, let's see. In your solution, what I've been encouraging you to do is to do your calculations in StatCrunch. Okay, that tells me that you understand the statistical problem and you're adept at using StatCrunch so that when you solve these problems in StatCrunch, you can easily now copy and paste your results, right? So we'll copy and paste these results right into the document. So let's go back to the document now. Let me open up your share here to our document. And now let's see. Let's go down here and paste it right here. Okay. And you know, when it comes in as your paste, you might have to resize it a little bit. That's not a big problem, is it? Okay. So here's our solution here. Okay, so this graph here tells me that you went into StatCrunch and you set up your problem correctly, and I can tell at a glance that you've done this correctly when you turn it in. Okay, so StatCrunch is really going to be the key for us from here on out. You've got a sample of it in your first 4 worksheets, and believe me, it will be a godsend for you in the next. Well, this is the 5th worksheet, yeah. So in the worksheets 5, 6, 7, and 8, you'll be using StatCrunch extensively. Okay. So you'll have something in your back pocket when you finish this class. You'll have an ability to use a statistical program to solve problems in elementary statistics, okay? And that was the whole point of asking you to purchase your StatCrunch software. Okay, other questions? Okay, any other questions before we sign off, or are you good?
No, thank you.
Yeah, I'm good. Thank you.
Everybody good? Okay. See, I have
Yes, good.
Estella, are you okay?
Yes, yes, thank you.
Estella, I think you logged in at 4 o'clock and I wasn't there. Sorry.
Yeah, I got it. Like I
Thank
was
you
able
for
to
coming
get
back.
it at 4:20.
Yeah, thank you
But it
for
was
coming back. Good. Thank you guys for, I may have lost a few of you, but thank you for hanging in there. Okay, if there aren't any last minute questions, I'll go ahead and end the meeting. Okay. And like I said, I'll be on standby all weekend, so you can call me or text me or send me an email, and hopefully I'll be able to answer your questions. All right. So Sunday midnight, your exam will be. Wait. Your exam will be done. Okay. Okay. So let's see. Before I end the meeting, so if you want to leave the meeting, go ahead and leave the meeting. And I have a chat here from a question from Josue. So Josue, are you there? Josue?
Yes.
Okay. I did have this question from some other students, and the worksheet may be locked for you because you haven't marked as done or read the module sections. So you're going to have to possibly, you were able to open up the earlier worksheets, weren't you, from Canvas?
Yeah.
Okay, so in your modules 4 and 5, make sure that you've read the assignments, you've marked them as read, and that will allow you to open up your worksheet and work on it, okay?
Great. Yeah.
And if you have any problems with that, you can text me or send me an email, or better yet, you can go back to the Canvas support folks, and they will help you, and you'll be able to open up your worksheet. Okay.
Great. Yeah.
Estella, are you still there, or did you sign out? I think she may have signed out.
No, I still here.
Oh, good. Could you share your screen for Josue?
Oh, at this time I'm connected on my phone because
Oh,
today I
okay.
needed to leave home
Okay.
for some stuff.
Okay.
But yeah, I'm sorry about that.
Yeah. Yeah, I was able to change my settings in my profile so that students could share their screens. Remember we talked about that on Tuesday?
Yeah.
Well,
Today I was trying to go back home early, but I couldn't, so I connected on my phone. I'm sorry about that.
That's okay, no problem. All right. So Josue, if you would go ahead and read through your modules, your previous modules, make sure that you've marked as read. It's a button that you must press in the upper right-hand corner of your Canvas page as soon as you read your assignment, then you can mark it as read. And, you know, some of you haven't read the entire section from back to front. You've read parts of it that were helpful for you in solving your worksheets. So just a heads up, Josue, you don't need to read all of it. But as long as you mark it read, then that will allow you to go forward in your module. And then when you get to your worksheet, you know, the previous reading assignments were the prerequisite or the requirement. And as soon as you checked and marked as read, marked as done, then you'll be able to open up your worksheet. Give that a shot, okay? All right, guys. Any other questions? Any other questions? Okay.
No,
Yeah,
no,
you-
I'm fine.
Go ahead. Go ahead. Go ahead.
No, I just said that I'm fine. Thank you.
Okay, good. All right, then I'll go ahead and stop the meeting if there aren't any other questions, okay? All right,
All
guys.
right. Thank you so much.
Okay, you're welcome. Thank you for joining, and I apologize for being late. That won't happen again. All right, thank you. Bye now.
Bye.